Good morning, everyone. My name is Xavier Ducrohet. I work at Google.
I'm Alex Ruiz. I also work at Google.
And we work on the Android plugin. So we're going to talk a little bit about some of the things that we are doing inside the Gradle plugin, how we're using Gradle, and some of the challenges that we have. So in case you're not super familiar with the Gradle plugin, it's very different from, even though we do build Java source code, it's very different from the Java plugin itself. We don't apply the Java plugin. We do apply the Java-based plugin in order to get access to some of the things that it provides, but otherwise it's very, very custom. We have introduced a concept of variants that now Gradle is starting to use itself, especially in the native plugin. But we have build types, which is debug versus release. We have flavors if you have multiple variation of your app. And by default, you always have two flavors. You have debug and release. Which is not like standard in the Java plugin. And because of that, as we'll see a little bit later, we can't use the standard Java source sets. We use configuration for dependencies, but we kind of use them in a slightly different ways than the regular Java plugin. And our task creation happen at a different time than the regular Java plugin. So a lot of things inherit from that. And we lost the animations. That's okay.
It's still open.
Do you have it? Okay. Yeah, let's switch to the other one.
Yeah.
There we go. Okay. We're going to hope that Wi-Fi is good and present from here. That way I can have my... all right. There we go. So I mentioned variants. So variants are a combination of a default or common setup that is applicable to all the variants, and then we apply one variant from each of the dimensions, and you can have 0 to n dimensions, and then one build type. And so, for example, if you have in build type, you have debug versus release, and then in your dimension, you decide to have two versions of your app. You have a paid app and you have a free app, ad supported or something like that. Then we make the combination, and you have 4 of them. So you have those, those debug versus release, paid versus free, and then you have also what we call common and default config that I'll talk about in a minute. And so, I mentioned that we can't use the Java source set, and that's for a couple of reasons. In the Java source set, in the Java plugin, when you have a source set, you have things that are associated with it, right? So you get the compile task, you get the configuration. So for example, if you have the default source set, which is main, you get classes, compile Java, process resources, all the tasks needed to build that source set. And then you get the compile and runtime configuration. And now, starting with 2.14, there's like a provided as well. So if you decide in the Java plugin to add a new source set, let's say foo, then you will automatically get separate tasks, completely independent from the main one, to build your foo source set. And you'll get foo classes, compile foo Java, etc. And it will really, there's no connection between the two. There's no dependencies. It's very separate. In the Android plugin, we do things very differently, right? We do, as I mentioned earlier, we have this common, configuration for all the variants. So we have the main source set, what you put in source main Java, would be something that's common to all the variants. If you have a debug source set that's created automatically for you when you have a debug build type, you have source debug Java, for example, then that's common to all the debug versions. So debug paid and then debug free. And then paid, the paid source set applies to all the paid variants. So debug paid and release paid. And then you have a source set very specific to the variant that you're trying to do. So because of that, as we create those source sets, every time you automatically, either by default you have those two build types, right? But if you have a third build types, we'll automatically create a source set that goes with it. If we use the Java source set, then we'll get those specific, task and configuration for that source set that we can't really use. That's what I said. So for the configuration, that's a little bit the same, right? We want compile to be something that is applied to all your variants. So if you do compile Guava, then Guava is available to all the variants that you have. And then we have debug compile, pet compile, and all of those configurations that are used, specifically for those dimensions. So when it comes to time to actually resolve those configuration, we can't just go and resolve compile, because if you have, let's say, Guava 17 in compile, and debug compile brings in transitively Guava 18, you want really to use 18, right? Everything should be promoted to 18. But of course, that only happens if you build with debug. If you build with release and release doesn't bring Guava transitively or directly, then you want to use 17, right? So we really want to resolve the configuration at the variant level. And that means that for each variant, we create a configuration that we put with an underscore, which is kind of crappy because it does show up in your dependency output, but it's underscore the name of the variant and then compile. We actually have a compile and a package separately because we have provided mechanism. And it's a composite configuration that we call, and it basically extends from all the other configuration that you use to set up your dependencies. I'll come back to dependency resolution. I just want to do one small thing on task creation. So each variant is very independent, right? You have debug and release are completely separate, which means that you can build both of them and they output in different folders, and they don't clobber each other's output. You can build just one if you want, but you can build both of them at the same time, which your previous AND-based build system didn't do at all. If you build release and then debug after, it would clobber the output. That was awful. So here we really wanted to have very separate output. One problem that we have is in order to actually build those tasks for each variant, the variant configuration, the variant computation, really we need to know all the build types that you have. We need to know all the dimensions of flavor that you may have, and we need to know all the flavors in each dimension. So that means we can't really do that as we're parsing the DSL. It's too complicated, right? As you parse the DSL, if you suddenly encounter a flavor, and so we can put listeners on the parsing of the DSL, and we could know, hey, whenever a flavor is added to the container, we could do something. But then you don't know if you've already seen all the dimensions, you don't know, and so we decided just not to do it, which means that we're basically doing everything in after evaluate. And that has a lot of impact on how we do things in the plugin, and it's actually a big issue. Okay, so let's talk about dependency resolution. So a typical dependency resolution, you're going to have your tasks somehow depends on your configuration object. Whether, for example, in the example that Luke was showing earlier in the previous talk, you have a copy and you do from configuration, and that's going to create a dependency on your configuration. And then, either you call my configuration.getFiles to get them, or because it's a file collection anyway, you can get access to it, and anything that receives the file collection can receive that configuration as well. And that's great, and that works for most use cases. It doesn't work for us at all. So the first problem is, so getFiles return a set of files, right? It's a flat list, but in our case in Android, we have a lot of tasks that require to receive the full graph. In particular, our resource merger want to see, for example, if you're depending on library A, which depend on library B, technically we have an override mechanism that means that A could override some resources from B, and you, as the consumer of them, can override some of those resources. So if you just have A and B in a flat list and you don't know which one actually depend on which one, if one is meant to override the other one, then you lose that transitive information. So that doesn't work at all. Some of the other problem that we have is, the Android library format, AR, is a zip file that contains a bunch of stuff, and we, unlike a jar that you can just pass to Javac and then it just works like that, it's also a zip file, but it just works like that. In our case, the AR contains a lot of different things that a lot of different tasks needs to access, and we need to unzip it first. So we can't just do get file inside our task and expect the task, any of the tasks consuming it to actually use it. So we need to unzip it first. And then it returns also all the artifacts. And we're starting to have case we announced at I/O Instant App. So you'll be able to create a library module that outputs both an AR to be consumed by a regular app or an instant app to be consumed by an instant app. And unless you want to publish them to different configurations, which means that consumers have to specify which configuration they want to consume. If you just want to say, look, I want this one to publish in the default configuration both my AR and my instant app, and have the consumer just pick the one they want, then doing getFile is actually going to return both of them, and that's not what you want. Not only it's going to return both of them, but if it's a submodule, it's going to build both of them, which is really a problem that we're going to have, and that's a limitation we need to fix in Gradle. So all of that to say we can't just do getFiles. And in particular, the fact that we want to unzip the AR means that we have to do all of that dependency resolution in the after evaluate, which means at configuration time, which is awful, which means that if you use the scanning stuff, you'll have that yellow bullet saying, hey, you're doing resolution at configuration. That's our fault. You can't do anything about it. It's something we do want to fix, but we're still trying to figure out exactly how we're doing that. OK, so we have something called a dependency manager that basically resolves the dependencies. So the first thing that we are doing is, as I mentioned earlier, we are always resolving the variant composite dependency that we are creating. We never resolve compile, right? Even though you do compile Guava, we don't resolve compile. We resolve the dependency one, which means that if you have a resolution strategy, you have to apply it to the proper configuration. And because you have variant, you can't just do configuration.all and then apply your resolution to all of your configuration, which would work technically, but then it applies to all the variants. So you really want to apply it to the one that you care about, the one specific to the variant you want to change, because you may want a different strategy on both variants. So you'll have to do something like that. And the first line is because as we're passing the DSL, that particular configuration that we create for the variant, I told you earlier that we create the variant in the after evaluate, but as you pass the DSL, we haven't created that variant yet. So you can't just go and do the second part, configuration dot underscore debug pet compile, because underscore debug pet compile doesn't yet exist. So in order to do that, you have to create it first, and that's OK, because when we try to create it after, we use maybe create instead of create, meaning that if it's already created, we just reuse the one that's been created already. So if you do that, just don't. You could technically start adding also dependencies to this one. It will work, but it's kind of weird. So you have to do that. Once we've started resolving the dependency, we're going to create a graph of all the dependencies. We're going to validate the dependencies. We're going to create tasks for them, to unzip the AR and stuff like that. And all of that, again, is done during configuration. OK, so let's look at the API that we can use in Gradle to do what we want to do. As I mentioned, get files is not what we want. It doesn't really work. Thankfully, Gradle has many APIs to deal with dependencies. So we use this one instead, configuration.getResolved, configuration.getResolved artifact, which return still a flat list of resolved artifact, but at least it has those two things. Get file, which is the artifact that either get built or denoded, and get module version, which give you access to basically the Maven coordinate of the artifact. So not quite what we want, but there's an additional information, the version, compared to just calling get files. One other thing also is that it's going to fail with an exception if a dependency is not properly resolved. And I mentioned we do that during configuration. So when we sync Gradle from the IDE and we ask the model to Gradle, it's going to do that resolution, and it's going to fail hard. And then basically, the tooling API would return an exception saying, hey, completely failed, and then we have no project information whatsoever. So instead, we inject an information, into the Gradle plugin saying, hey, you're being called as a sync from the IDE, so please be a bit lenient in the way you do things. And instead, we call a slightly different version of the API called getResolved configuration, getLenient configuration, getArtifact, and then that doesn't actually fail, but it returns instead for some artifact, the type will actually be like unresolved artifact or something like that, and then we can figure out whether they're resolved or not. OK, so we got a flat list of something that's not what we want, but there's another API. So we do configuration, get incoming, get resolution result, get root, get dependencies. And what we get is dependency result, which is actually in the case where it's resolved, a resolved dependency result, which contains this resolved component result, which contains those two, a module version, and a list of dependencies. So you get basically a graph, and you get, again, a module version, but you get nothing else. OK, so basically, I'll talk about it after, but obviously we have the graph and the flat list, and then we can recombine that. We recently discovered a problem with this API that's very strange, but apparently normal, but it's still strange from our point of view. So let's imagine that you have an app, and you have two modules, right? You have an app module, and you have a test, like a project that contains fixtures to test your code. So your app test depends on the fixture module. And the fixture module, well, it needs to know the classes that it's testing, so it's depending on the app itself. There is technically no loop here in your dependency, but if you call the second API, the one that returns the dependency result, it's going to complain that there's actually a loop because somehow it just deals at the module level and not at the actual artifact that is published, right? The test artifact of app is never published, but still you get like a loop, and then because we do that, we detect the loop and we complain saying, hey, you have a loop in your dependencies, and all the users are saying, no, I don't have a loop in my dependencies, and they're right. And so talking with some of the Gradle folks, it's normal because it works at like the component module, so it's not clear what's going on there. But it's a limitation of that API that we just encountered recently. And also another note is that when we start publishing multiple variants, like if you want to publish both a debug and a release of a library or something like that, all the things that we talked about recently, those two API return the Maven artifact. But unless you manually go and if you do something like that, unless you manually set up some classifier on top of the regular group ID, artifact ID, and version to differentiate those variants, like you're going to have a problem because in general, a Maven coordinate is really just for like a full module, right? It's up to you if you publish two different things to add classifier on it. Okay. So we saw two APIs so far, and to our surprise, those APIs don't actually return any local jars. So if you have a jar somewhere in a lib folder and you depend on it, well, you just don't see them. So third API, configuration get all dependencies actually returns a flat list, again, of dependencies. But if they're of type self-resolving dependency, but not of type project dependency, then they happen to be local jars. And so then self-resolving dependency has a resolve list of files, and generally it's just one file because the dependency, if you just do compile foo.jar, then you'll get just a single foo.jar in there. And we don't care about the version here because it just, there's no versioning anyway. So once we're done with that, we do validation. So this is very Android specific. It's something that you don't really care when you do just pure Java, but first, we don't really support, so we have a mechanism to support provided dependencies that are compile time only and not runtime. But we don't support that at the app level because it doesn't really make a lot of sense. We do support that if you're building a library because you could have a dependency that, it's up to the consumer to figure out whether or not they want to include it. We don't support that at the app level, so we have a quick check to make sure that you don't have that kind of dependency only in your compile tree and not in the runtime graph. We also compare the test and the tested dependencies. And that's because, in Android, you're going to have, first, everything gets packaged into your app, right? So if you depend on Guava, it gets packaged into your app. And then if your test also depend on Guava, but different version, it's going to get packaged into the test app. And then you load that into the same VM, and or verifier at runtime will look inside the code and look at all the classes and see the second version of all the Guava classes and say, well, I already saw it, so error. So we have to manually go and remove them. So you can depend on them. And if they're the same version, we say, OK, that's fine. We'll put them on your compile class path, but we won't package them. But if they're different version, then we'll complain and say you have to resolve because ultimately everything's going to run in the same class path and needs to be of the same version. And so we do that kind of, so internally we have skippable library.skip, and we just skip it and then it doesn't get packaged. So a lot of Android-specific validation there. Another issue that we have with those APIs is when we want to test a library. So when you want to test an app for Android, inside the module, we create really two apps, right? There's the app and the test app. And we deploy both, and they run in the same VM, they test. When we test a library itself cannot be uploaded to a device and run there because there's nothing to be run, right? It's something meant to be consumed. So instead, the module outputs a library that can be consumed by another module, and it outputs an app that consumes that same library plus the test code, and it's a single package. And Android can have the test app, the test code inside the same app that it actually tests. It's self-contained, and we just upload that and run the test, and all of that is there. But we want to represent that properly in your internal model, and what we want to do is have the test app depend on the library, and then have that library brings in its transitive dependencies. And we can't actually do that. We can't make it depend on that artifact. And so instead, what we do is the test dependencies extend from the regular dependencies. So they're bringing those transitive dependencies. But then we also add kind of like in our own model, we add the actual output there. So technically we have all the dependencies, but the graph is wrong, right? Because it looks like the transitive dependencies of your library show up as direct dependencies of the test app rather than being brought as transitive dependencies of the library. So it technically works, but there could be issues, and it's something that also we want to fix in the future. So variant publishing is not something that's very specific to variant resolution, but it's impacted a little bit somehow. I talked about the fact that we have debug versus release, and when we publish a library in a submodule, and you have an app, and both of them have debug and release, you do want debug to consume debug and release to consume release, right? And it's something that Gradle doesn't really support yet. It's coming, with a lot of work has been done with a native plugin to do variant-aware dependency management, but it's not present in the current plugin, and it's not quite there for being used by all the plugins. So it's something that we want to be able to do. Right now, if you want to do, we can, in the library, say, hey, I'm going to publish all of my variants, but then you have to do something like debug compile, project, and then configuration debug, which works if you have just debug versus release, but if you have many variants in different dimensions, or if you have, it becomes kind of complicated to deal with. So it's something that we want to work on. OK, next I want to talk about extensibility a little bit. So first, task access. I mentioned that they're all created in after evaluate. So if you use some typical Gradle API, like just doing directly in your DSL, task name depends on, well, that task has not been created. So you would have to put that in after evaluate. Same thing with get by name. That's not a live collection, so it wouldn't work. You would have to put it in the live collection. You do have some live collection that works, like with type or matching or things like that. But those are not variant aware. So you would get, and I mentioned that all variants have very separate set of tasks. So let's say you have 5 variants, and you ask for the Java compile version. You're just going to get 5 Java compile version, and which one belongs to which variant you don't really know. Technically, the name of the variant is in there. So you could, but we don't really guarantee that the name is stable, so don't do that, which is a problem. But we also, we are trying to optimize a lot of things in terms of performance, and sometimes we're removing classes or adding new ones, and it's dangerous. So instead, we created a variant API. So it's a live collection too, so you can put it in your DSL. You don't have to deal with after evaluate, and it will work anyway. And so if you have an application project, you do application variant.all. If you have a library project, you do library variants.all. And then for both of them, you can do test variant to access to the test variant. I was wondering what that slide was. Ignore that slide. It was like way in advance. It must have got moved by mistake. So the variant API. So we do have getter for some of the tasks. And here the name is meant to be stable. So get merge resources will return you the merge resource task no matter what its actual Gradle task name is. Then we get access to some names and folders. So get name is the name of the variant, which is unique. So if you need to create a custom task for this variant, what we tell our users is create a name that contains that get name as well. That way, between the prefix, let's say, of the task that is very specific to your task and therefore must be unique, and the variant name, that combination should be unique, and you can just loop on all the variant and create that, and you won't have a problem. Because if you just loop on all the variant and create a task called foo, it's going to work the first time, and the second time Gradle will say, well, there's already a task called that, you can't use it. And then dir name is also a unique folder for you to put stuff of your task, and it's per variant as well. You can get access to a bunch of other stuff. We have a couple of methods on there, like register resource generating task, where you can technically tell us that, hey, I have a task that generates resources, please, handle it, and we set proper dependencies and things like that. And that was a beginning of, we want to have an extension API that allows you to easily add tasks. But it's still really technically difficult to inject new tasks into your pipeline, and a lot of developers want to do that. And that particular example is an example where a lot of people want to add custom tasks. So it's between basically compiling your Java source code into Java bytecode and us converting it into a different bytecode that's the one that Android is able to run. And in between those two steps, we try to do a lot of optional steps, like running Jacoco, running ProGuard. And then we have a lot of external developers that are telling us, well, I want to do retro lambda, I want to do, some, instrumentation for analytics and things like that. And there's multiple services that do that. And, how do I deal with that, right? And then it's become like a crazy thing. And then we introduced Instant Run last year, where we do a lot of instrumentation in between. And it was really becoming a big mess there. So, to inject a new task, really, you have to find the two tasks that you want to do. The previous one to grab its output, the next one to grab its input, and you want to, inject yourself in between, rewire that, and you want to do the dependencies between the tasks. And that works fine if you're the first one doing it and you know what our task is, the Android task for the compilation task and the DX task. And you can go find those two tasks and insert yourself. But if you're a second plugin that arrives and do the same thing and didn't realize there was another plugin that did the same thing, you technically want to insert yourself at a different point. And it just doesn't work. And then there's other issues where it's relatively easy when you think about, let's say, regular Java plugin where those tasks really deal only with the code of your project. In Android, as I said earlier, right, we package everything into the app. So, is that really accurate? Not really, right? If you look at something that uses both Jacoco and ProGuard, it actually looks like that, right? Javac outputs something that's the current project, but what we inject to Jacoco is that stuff plus stuff coming from submodules. And then, because generally you don't want to run Jacoco on like Guava, you don't care, right? You don't care about the code coverage there. But ProGuard, goes and look at everything, obfuscates, shrinks everything, so it needs to find all the inputs. So the output of Jacoco plus the output of all the external libraries that you consume. So here now suddenly actually finding out where you want to insert yourself depends on what you want to work on. Do I just care about instrumenting the output of the current project, or is it all the users' code and things like that, right? And then it becomes very complicated. Well, even if you're just the first one to do that as a plugin, or if you're like the second or third one, and it becomes a problem. So there isn't really anything in Gradle to help you with that. So we kind of created an API for that. We call that the Transform API. It's basically a pipeline of transform. What we did is we completely abstract all the Gradle part. It's somewhat Android domain specific. We just ask user to provide you with a transform, and the transform tells us what they want to transform. So we support class files, we support resources, decks, native libraries. So you can just say as a transform, it's like, hey, I'm transforming class files. And then we have a notion of scope. Is it the current project scope? Is it the sub-project? Is it the external libraries? Is it the tested code? Because like ProGuard, if you're ProGuarding a test app, needs to have a reference to the tested code, because otherwise it's going to find classes that is not part of, it's going to find reference to classes that is not part of the code it's seeing, and it's going to complain. So we have to provide them with a separate type of input into that. And so as a transform, all you have to say is what you want to transform, which scope, and then basically we call you, as you set up new transform, we do the proper dependency to figure out what's the previous transform that output that kind of scope and content, and then we do the proper matching, and you don't really have to care about anything. So it simplified your own code a lot, because we used to have a lot of so if Jacoco was created, when I want to create, when I want to set up the ProGuard task, then I have to figure out what's the output of Jacoco and what's the output of Javac, and it was just like a complete mess. Now it's just like, we have a bunch of transforms that properly describe what they're trying to do. We just, apply them one after the other one, and then our transform manager just takes care of doing all the dependencies. And then it's helping a lot for external developers who want to do the same thing. We have some issues, though. It's kind of very inflexible. The order is really the order of application, right? If you try to say, later I want to apply something at the beginning, we can't really do that just yet. And our API is not variant aware. Technically, we are variant aware internally, but you can't, as a user, apply your transform to just one variant, which is something we just need to do. It's not a very big deal, but it's something we need to do. So it's been a really huge help in that particular context. I think it's something that, having a generic mechanism in Gradle would be awesome to do. It's probably a lot more complicated than doing something that does exactly what we wanted it to do, but it's something that really helped us a lot to make our plugin extensible. Next, I want to talk about performance a little bit. There's really three types of performance. There's our own tasks, that are slow, clearly, our fault, we're working on that. There's some bottleneck in Gradle itself, and then there's, some parallelization issue that I'm going to talk also a little bit about. So for our own task, what you hear from developers is Javac can take a long time, especially those running with annotation processor, which is more and more Android developers do that with things like Dagger, for example. Resource compilation, which is something we're working on. Dex conversion is also something we're working on. And we're really excited. There's a lot of fix and improvement happening in incremental Javac in Gradle itself. So we're working closely with the Gradle team to make sure that the incremental Javac is really good. So that progress is being made there. In the Gradle bottleneck, Hans has shown some good configuration improvement. So we're excited to test that. There's something that it's not going to be as good as the new model where it can do only what's needed. So we want to do some of that. Faster dependency resolution is definitely something we're excited about. I think also in our case, we want to do only what's needed. So we want to try to move it into being at execution time rather than at configuration time. That will help a lot. I heard from a developer, they had about 1,000 configurations that were being resolved. Because in an Android module, you have debug release, then you have the test, then you have the unit test, and the unit test release. So that's 5 variants really, and each of them has 2 configurations. That's 10 configurations, and they had 1,000 because they had almost 100 modules. And it took 3 minutes to do dependency resolution because it's not parallelized right now. There's a big lock around it, so it's single-threaded really, and it just does more than it needs to. So we need to fix that. And then the task level parallelization is really something that we want to do, but before we can really do that or benefit from it at the Gradle plugin, we want more granular dependency. So let me give you an example of that. So let's say on the left you have a library. We're going to create an AR. So first we need to create the content of the AR. So there's new classes.jar, that's the code, the manifest, the resources, and it's coming from some task. Then we're going to zip it. And that's because we want to create something that potentially the Maven plugin can grab and publish somewhere, right? So that's what we publish. We publish a big zip file that contains all of that. But then on the consuming side, when it's just a sub-module or sub-project, right, we're going to start by unzipping it. And then we're going to get the same thing and then send that to new task, right? So in that case, compilation, we use classes.jar as a class path entry. Well, really what we want is that, right? We want to be able to, publish all those different components and have the consuming, and also we would also, of course, publish the AR, and then on the consuming project, if it's like, something like that would consume all the different parts, and if it's a Maven plugin, then it would consume the AR and deal with it. So it's really something we want to get. Okay, and now we're going to talk about ID integration.
Sorry. Thank you, Seth. So one of the vision behind Android Studio is to be a build-centric IDE. And what do we mean by build-centric IDE? So the first thing is that the build system, in our case, Gradle, is the source of truth. So this means that when the IDE creates a project or opens a project, we get all the information, source folders, dependencies, libraries, from the build system. Everything that has been declared in the build system is translated into the IDE. This is possible thanks to Gradle Tooling API. Without actually executing a build, we can query Gradle to give us models containing this information so we can configure the project. In the case of Android libraries and Android apps, it's very straightforward because we take care of that. We provide models that provide all the Android information. But for Java libraries, it has been quite challenging because there is no dedicated Java model from Gradle. So to overcome this limitation, what we have done in the IDE side is to transparently apply plugins to each of the modules of your project, and then these plugins provide a specific Java models that have information that we need to set up a project. This information is, for example, the Java language source level, the location of the build folder, also the artifacts per configuration. We need all that information in order to configure an Android project properly. So the second aspect of being build-centric is that we don't want the IDE to use its own infrastructure to build a project. Android Studio, instead of using IDEA's infrastructure, delegates the build to Gradle. So this means that you're going to get the same build output regardless what you use. So IDE, command line, and continuous integration server are going to have the same output. Also, we have to be very careful not to take this build-centric vision too far. What I mean is that we don't want to expose every single detail of the build system in the IDE. As a developer, I want to use the actions I'm used to, the default menu items, the default keyboard shortcuts that I use to do common actions. For example, to build a project, to run tests. I don't want to memorize a specific Gradle tasks. What I want to do is go, build the project, click the same actions that I always use in my IDE. So because of that, Android Studio, under the covers, calls the appropriate Gradle task for you. So for you, it's just working with an IDE. We take care of the rest. Another aspect is that Android developers have told us many times that it's very difficult for them to make changes to build their Gradle files because they have to memorize the DSL, or they have to fall back to documentation or Stack Overflow. They lose a lot of time. So to overcome this limitation, also we're actively working on a visual way to configure your project. And that visual way is the project structure dialog. So we have replaced the default project structure dialog in IntelliJ IDEA with our own. This one is Gradle-centric. So it hides all the complexity of the DSL. So folks developers don't have to learn DSL. And this is it's going to get complicated pretty soon, because right now, just with the Groovy-based DSL, we have two DSLs, one for the regular plugin and one for the experimental plugin. And once Gradle supports Kotlin, there's going to be 4 DSLs. And developers have to deal with all that. So instead, we provide a form, fields, where people can just configure their builds. But what we're trying to hide is the DSL aspect of the build system, but we still expose Android-specific build concepts. For example, you still have to learn about product flavors. You still have to learn about build types. Also, this project structure dialog gives you some extras. For example, displays a nice tree of resolved dependencies per module and also at the project level. So you don't have to go to the command line to see this information. Also provides project structure checks, just like the checks that you get from lint when you open a build or Gradle file. Those checks are going to be there. Also, you're going to get all the warnings, errors that Gradle gave you there in one place. And the last one is checks for available dependencies updates. For example, you're using Java 17, and then the project structure dialog is going to say, tell you, hey, there is 19 out there. You want to download it, install it, and you click, and that's it. So the heart of the project structure dialog is a parser that we have written. This parser is based on IDEA's Groovy PSI, which is a great AST implementation. It's not just a parser. It reads the contents of build or Gradle file, creates a model out of it, but also can apply changes back to that model. And that means also apply the changes to your build or Gradle file without breaking it. It's limited to Gradle DSL. We make the decision not to try to parse any Groovy scripting because it's going to be impossible and we're going to get it wrong anyway. And also supports different DSL notations. And I have an example. So here you have 5 different ways to specify the application ID in an Android application. And our parser supports all of them. If you want to change the application ID, well, not yet, but eventually, if you want to change the application ID from the project structure dialog, you can do it, and the parser will take care to put it in the right place without breaking the structure of your file. Oh, and there is a demo. Uh-oh. OK. So here, this is the application, the I/O schedule for Google I/O application for this year. Now, what I'm going to show you is the project structure dialog, the new one. It's available under an experimental flag because it's not finished yet. We're working on it. But here you can see some interesting things. First, it tells you a warning that you should avoid using the plus sign in the version when you specify a version of a library. You have a hyperlink there to say fix, and it will resolve to the last, to the actual resolved dependency, and that will be applied to your build.gradle file. There's another information message that this library, Mockito Core, has been promoted by Gradle from 1.10.8 to 1.10.19. So that version comes from Gradle, and we can display that there. And here, the prehistoric dialog is going to parse your build.gradle files, find out what are the repositories that you're using, for example, JCenter, go fetch the latest version of all your dependencies, and if there are some available, it will show them there. And then you can go and update them. The next thing is dependencies. This is one of the most difficult parts to implement. So the first item, all modules, is going to give you a global view of all the dependencies in your project. And here you can also see transitive dependencies, for example, there. And on the right-hand side, you're going to see like the selected dependency on which modules is applied and the scope. So maps, utils is in Android module, scope compile, and it's declared. It's not transitive. On the bottom, you're going to see details about the selected dependency, group ID, artifact name, and there's some messages that are specific to the dependency that you saw from the previous view. Also, if we want to edit a dependency, you go to a specific view for the module, and here you have on the center, what you have there is the list of dependencies that you can edit or delete. You select one of them, and it's going to show you details about the dependency. For example, let's see. Details, the warning that we saw before, and there is an update available. And to fix those things, you just have to click once. On the right-hand side, you're going to see a tree with all the transitive dependencies. So for example, app.compat brings all this. And you're going to see it per artifact. Another thing that you can, this is something I wanted to show you. So server is a Java library, and it doesn't have that view with transitive dependencies because there is no way for us to get that information, a nice graph from Gradle. So for this, to implement this, what we have to do is to use the same mechanism to inject a custom plugin which provides a model, and we implement that model that provides this nice dependency graph from a Java library. And the last thing I wanted to show you is how you add dependencies here. So here, this is a dialog where you can search for dependencies, and it's going to search in the repositories that you specify in the build.gradle file. So for example, if you have JCenter and not Maven Central, it's going to look only in JCenter. If the module is an Android module, it's going to also look in your Android SDK. So let's see. So now we're searching, and here, for example, for juice. And here all the possible juice artifacts that you can use. So we didn't specify in the group ID just the name. So these are the results. And each result has all the available versions. You select one, and here you specify which is the scope. But the thing with Android is that the scopes are a lot more complicated than Java, because you have the configuration name, for example, compile, and then you have the build type and the product flavor. OK, so instead of doing that, you just select what you want. And here, you're going to see the scope is automatically computed for you. I'm done.
OK, so just one last thing that I wanted to talk about. Earlier Alex said, hey, we want the same build output, whether you're in your CI, command line, or ID. Well, almost. It turned out there's a lot of cases where we don't want to do that. in particular, because when you're building on a CI server, you really want to build something that's going to be used in a very generic way. But when you're working at your computer with one device connected to it, you don't really want to do that. So for example, when you're building on your debug version, you really just want to build your debug version. As I said earlier, right now we do too much at configuration time. We're also going to do dependency resolution for the release version, and that's a problem. So what we do is, as earlier I said, we inject some property into Gradle, into our plugin when you're from Studio during sync in order to be more lenient around dependency resolution. Here we're going to say, well, for that particular module, I'm just trying to build debug, so just keep the configuration and the creation of the variant that is not the one that I'm trying to deploy, and that way we get speed gain. We can't do that for every module. We can mostly do that for the main module and for some libraries, but it depends. If you start publishing really both the debug and the release of a library, we can't really do it. But if you only publish the library, we know you're not going to use debug, so we don't configure the debug one. Something else that we do is very specific to a device, right? If you're building native code and you're building ARM code, x86 code, MIPS code, in 32-bit, 64-bit, just adds up to a lot of APIs. And if I'm deploying to a device that's ARM 64-bit, I just want to build 64-bit. I don't care about the other one. So again, we inject stuff into it. And here it's really changing the build output because we can't, we have to inject that in the task saying, just ignore the other ones. Now, if you go right after that build, if you go from the command line and you build a regular one, the input technically of the task will have changed, so it will consider them not up to date and it will rebuild them because of the up-to-date check of Gradle. But when you're building from Studio, we have to do that. Same thing for packaging densities of assets you don't care about. It's just a matter of making the build from Studio as fast as we can based on the current device connected. So we're starting to do more and more of that in order to make working from Studio with Gradle as fast as possible. And that's it. Thank you. I don't think we have time for Q&A, but we'll be around if you want to ask us a question. Feel free to come and talk to us. Thank you.